Hi, I'm Cullen. Welcome to Networking Fundamentals. This is Mod 1. We're going to focus on understanding local area networks. Thanks for joining me. Really excited to teach you about networking. Let's get started. Quick overview of our agenda. We're going to discuss local area networks, talk about data transfer on a local area network, also known as a LAN. And we're also going to feature the different types of local area networks that you might come across. All right, local area networks. So first, what is a network, right? A network is just two devices that are connected to each other with a physical medium, like a wire cable or a radio signal. This picture here, just a wired cable, like an Ethernet cable. The connection allows two devices to just exchange data back and forth. So there we have some data moving across, some binary there. We'll talk about binary in a little bit. Networks have a lot of different purposes too, okay? They're used for communication and collaboration inside of a business or an organization. They allow us to share information and resources like text and tweets. They make it possible for us to organize data. They also allow us to save a lot of costs because we can share resources like printers and other different services that are available through networks. All right, so how are networks organized, right? Like we have all these devices around the world. How are they organized with one another? Not just around the world, but also inside of the same building. They're organized based on their geographic location or where they are in the world, in a building or in a city. A local area network, or a LAN, is simply a group of computers or devices that are featured in the same small geographic location, right? So like a school or a small office. They all share a common communication medium. So, you have cables like we talked about earlier, or also wireless connections. They're also connected to something called a central connecting device, which we'll detail here in a little bit. Those can be hubs, switches, or routers. All devices that are very important to learn about. Network documentation, I guess. If you're designing a network, you have to define and describe and explain how different devices on a network are connected, right? We want to know the physical location of each of the devices and also how they're connected logically, like the general design, right, that we have up in our brains. The documentation phase occurs before you actually build networks or whenever you make changes to a network. And I just want to highlight Microsoft Visio as a tool that can be used in order to design networks on your PC or on your laptop. All right, so what devices make up LANs? We've got hosts, right? Your phones, laptops, desktop PCs, servers, and tablets. We also have central connecting devices, which are hubs, switches, and routers. We typically interact as users with host machines. Those host machines then connect to central connecting devices, which are responsible for relaying our data to other host machines. Hosts, we already detailed the different types that are available, right? The different kinds that there are. But a host is defined as any device that has something called an IP address. An IP address is used to send and receive information. It's very similar to your mailing address for your house. Pretty good way to remember what an IP address is and what its function is. And IP addresses help identify not only the device, so like your house, right, but also the networks where they're located. And if we go back to that home address analogy, a network would be sort of like your city or maybe even your street block. Central connecting devices, as I mentioned previously, are for connecting hosts and also transmitting data. Different central connecting devices, they perform these functions in different ways. And I'm going to show you, model for you those different ways here in just a second. Okay. First, we'll get started by talking about hubs. Hosts send data to a hub, and then a hub then broadcasts that data to any other device that's connected to it. This is sort of an antiquated technology. It's old and becoming more and more obsolete, if it isn't entirely obsolete already in most parts of the world. But what happens is it is going so this computer, this device, like you just saw in the demonstration, sends its data, and then every other device that's connected to a hub is going to receive that data. The difference, though, or rather a potential problem here for us, is that this computer may only want to send data to this laptop down at the bottom of the screen and not to the server that's located up at the top right. We're able to correct this problem with devices called switches. And unlike hubs, switches send and receive data simultaneously, and they also send it directly to its intended destination. So take a look at this example here on the right. Okay, so you've got data being sent simultaneously, not even necessarily between two different devices, but amongst different devices entirely, and they go specifically to their intended target. So you saw the yellow piece of data there go from the PC to the laptop, and you saw the turquoise or green piece of data there go from the laptop to the server. Okay, and switches, I guess a good way to summarize it is switches are just simply smarter than hubs. Let's talk about routers. Routers are at the edge of a local area network, and they're the devices that are responsible for connecting us to the internet. Okay, they act as a gateway to other networks. Okay, routers allow communication between hosts on different local area networks. So we can actually connect to local area networks via a router, and that's actually how you make up the internet, right? You connect a bunch of local area networks to each other. Here's a quick example of that data going out to the internet. Pretty cool stuff, right? All of these devices connect to each other via network adapters, right? Network adapters are also known as network interface cards, and these are the pieces of equipment that make it possible for computers and even our cell phones to communicate with each other, right? NICs communicate via wires or wireless signals, and this guy right here, this wired adapter, it features something called an RJ45 port. Wireless adapters feature an antenna in contrast, and they connect to networks using wireless access points, which are, they're also an essential connecting device, and we'll detail them a little bit later in a different module. And of course, if we go take a look at our RJ45 port, we have to have something that we can connect that to or connect that with. And what that is an Ethernet cable, right? Ethernet cables are made of copper wires. They transmit data in the form of electrical pulses. Okay, wireless communications, they rely entirely different technologies, radio signals. Okay, so keep in mind that copper cables transmit data in the form of electrical pulses. You may have heard me mention binary data earlier, and electrical pulses, if there's a pulse, it might represent a state called on, and if there is, so let me write pulse here real fast, and if there is no pulse, then that represents a state called off, all right? We normally say a pulse would be like 1, on would be represented by a 1, and then no pulse would be represented by a 0. And that is called binary. I apologize once again for my atrocious handwriting. So here we will talk about wireless access points just a little bit. They provide a central point of access for laptops and cell phones and even PCs and households, right? We can wirelessly transmit data to these wireless access points, which are actually connected to switches and to routers, right? So even though we access a network wirelessly, that data still is transmitted across a wired network, which I think is something that's super interesting. I'll just point out that little wire there. All right, so now let's switch modes and talk about data transfer on LANs. Data is transferred through serial data. Data is transferred in a serial format. So that means 1 bit of data at a time is sent. Now data can travel in a single bit stream in both directions, like to and from. And how it does that depends on the type of connection. And you've got a couple of different types of connection. There's something called simplex, which is like a one-way street. So data can only transfer from one device to another. Whereas we also have something called duplex, which is like a two-way street, which means that the data can be sent and received at the same time. There's also another format called half duplex, which means that you have 2 streets, but only one of them is in use at any given point in time. Okay, so data can only be sent to and then also sent from, but not at the same time. Okay, all right, move on to the next slide here. The speed that data travels is measured by bits per second, right? That's called its data transfer rate. So we signify this data transfer rate as in, we've got the number there, so 10, right? And then M, which in this case stands for mega, right? And then we have a lowercase b. This lowercase b is a little bit different from the type of data that we store. It represents bits, right? Not to be confused with a capital B, which would represent bytes. This whole construct down here, right, is called the bit rate. And we use that to measure how fast data transfers over a network. So before data is transferred, it actually goes through this really interesting process, right? We break large chunks of data into things called segments, okay? Addressing information is then wrapped around that segment, and we call it a packet. From there, we then add a little bit more information in order to make it something called a frame. And then each frame is broken into the bits that we see on the screen. This visual might be a little confusing, but just know that really data is ultimately going to be represented in bits before it's transmitted across a network. So this whole thing ends up taking this form right here. And then it's transferred over a physical medium in binary. All right, and of course, when data is received by a device like your cell phone, it goes through the reverse process. So what happens is that the receiving computer is going to go ahead and take all those bits. It's going to read the frame, or rather, it's going to reassemble the Ethernet frame. It's going to strip that physical addressing information, and then it's going to strip the logical addressing information known as the IP address. So it's no longer a packet anymore. It's going to come back into its segment form, and then it's going to be reassembled into the file that we click on in Windows Explorer, which I think is a pretty cool process, and it actually really simplifies the way that data transfer occurs. All right, so how does data know where to go? Well, we mentioned IP addresses, right? Those are logical addresses that uniquely identify a device and its network. So an example here would be 192.168.1.1. Every IP address is broken down into 2 different parts by something called a subnet mask, which we'll detail here in a little bit. And so we have a network ID portion, which is 192.168.1, and then the host ID, which is 1. This network ID, think of it as like city and state, I guess maybe your street name. And then we also have the host ID, which would be like your house number, right? All right. Another thing that's really worth mentioning is that IP addresses, the way that they appear, note these little dots that split up the different numbers. Those separate octets. We'll detail IP addresses a little bit more later, but octets actually are just 8 bits. And there are 4 octets in an IP address, which means that an IP address is 32 bits, so 32 zeros and ones. Like I just said, we're going to go ahead and touch on the subnet mask now and detail that a little bit more. A subnet mask is just a group of 4 numbers that define a computer's network. All right, so if you look down here, 255s represent the network portion of an address. So 192, 168, and 1, just like in the example that we just saw. Okay, and then a 0 is going to represent the host portion. So if I change my slide color, or sorry, my pen color here, this 4th octet is the host portion, right? So that's like our street address. In contrast, over here, everything that is represented by a 255 is going to be our network portion. This is really important for us to keep in mind as we're learning this. We'll revisit it throughout this course. All right, so finally our last little objective for the day, types of local area networks. Wired LANs come in different forms, right? And we have these wired LANs where each PC is connected to a central connecting device, whether it's a router or a switch, via an Ethernet cable, right? A copper-based twisted pair cable, in fact. We also have our wireless LANs, where each of our devices are going to connect to a network via Wi-Fi signals, right? Radio signals that transmit data ultimately onto a wired network. And finally, we also have a very special type of LAN called a virtual LAN. Virtual LANs can be wired or wireless. In this example, they're all wired, right? And VLANs allow us to group devices based on their functions. So in this example to the right, we've organized our computers on our network based on teachers and students. So I've tagged any data that comes from the VLAN 30 teacher computers with just a little bit of information, a little bit of data that says, hey, these computers can communicate with each other as if they are on the same physical network. If VLAN 20 tries to communicate directly with VLAN 30, if those devices try to communicate with their counterpart devices, then it's going to be treated as if they're on a separate network entirely, right? So do keep that in mind. We'll detail VLANs a little bit more later on in the course, but super important to keep in mind, right? Also, physical location of these devices doesn't matter at all. Where they're located, these two, you could have two devices sitting right next to each other, but they could be treated as though they're on completely different local area networks. It's a really cool technology and something that definitely makes it a lot easier for you to manage a network and potentially even keep some devices more secure than others, or provide different sets of rights to devices based on their organization affinity. All right, next we'll go ahead and take a look at the following slide here. Perimeter networks. Perimeter networks are really interesting to me. They're also called demilitarized zones, but they're interesting because you have your local area network down here at the bottom, but then you also have your perimeter network, which sits outside of a local area network. And what you do is you typically allow web servers to sit inside of a perimeter network so that people who are accessing your network or resources from your network to access them without giving them access to your local area network. So all of your private devices and maybe even private information of your employees. You're going to see these typically implemented in organizations and businesses that have web servers or provide hosting for websites or for email, right? Like I said, just to reiterate, the setup allows users outside of an organization's LAN to access those servers and those services, but not the organization's local area network itself. Okay, keep that in mind. All right, so thanks so much for joining me here. We'll just do a quick recap of our agenda again. Covered objective 1.2, understand local area networks. We talked about what local area networks are, just data transfer in general on a LAN, how data gets from one place to another, and also the different types of local area networks. I'm really excited to continue our journey through networking fundamentals again, so I'll see you in just a second in Module 2.